Standard form. So we're just going to have a bit of a recap on standard form. Now I know you did a little bit of work on this, some of you, before half term, but I wanted to do a kind of just a little live recap of what it's all about, just to give you a bit of a help. So some of this you'll probably go, oh yeah, I remember that, and other bits you might, might be useful. Anyway, standard form is just another way of writing numbers. They are just numbers. That's all they are, just ordinary numbers, just written in a slightly different way. You think, well, we've got a perfectly good number system. Why on earth would we use another one? Well, this is because it's really good for either writing very small numbers, and by small numbers, I mean, the sort of things when we're talking with atoms, and we've got all these things with a decimal point and loads of zeros. That's a really clumsy number to work with. So it's that kind of thing that we're talking about. Or possibly just really, really big numbers. So if we're working usually with like anything to do with space, suddenly space is like really huge and works with really high and low temperatures and things. And so we could be talking about really big numbers. And it's just so much easier to use standard form because, again, this number's really clumsy. Right, standard form has two parts. It is made up of this bit at the front, which is like a decimal part, so 2.45. And then it has usually followed by a single digit, yeah, so followed by a decimal point if necessary. It doesn't always have a decimal place, but what there is just one single digit at the front, and that front digit cannot be a 0. It must be a 1, 2, 3, 4, 5, 6, 7, 8, or 9. It can't be 2 digits, it can't be 0, it must be just an ordinary number. And there might be a decimal bit after it. And there's also a power of 10, so 10 to the power of 5 in this case. Okay. Now the reason we do this, let's start off with say 2.45. What 2.45 is equal to 2.45, right? It's arbitrarily right. It's just is, isn't it? What if I times both sides of that by 10? The left side, I'm just going to write that it's times by 10, but on the other side, I'm going to have the answer. So if I times it by 10, my decimal point moves. Decimal point doesn't really move, the numbers move, but I always talk about decimal point moving because I'm old-fashioned. All the numbers shift across one place to get 24.5. Okay, let's do that again. So I'm going to times the left-hand side by another 10, and the right-hand side is now 245. All right, these two things are still equal. If I times this number by 10 twice, I get 245. But look, this bit here, this bit, where are we there, but the times 10 times 10, it's just a little bit clumsy. So we could neaten that up quite a bit, couldn't we? Instead of writing times 10 times 10, why not put times 10 to the power of 2? Because it's 10 times 10, it's times itself, it's to the power of 2. All right, that's basically what we do. We neaten it up. Okay, in fact, every time I times it by 10 again, instead of just writing times 10, I'm just going to increase my power one more time. I'm going to times it by another 10 here. So it's 10 cubed. This number will move one place bigger. So 10 cubed is 2,450 there. And if I times it by 10 again, my power gets one bigger. My number over here gets one place bigger. This one gets one bigger. We get one place bigger. And look, we're now actually back to our original standard form number. So this is what standard form does. The times 10 bit, all it's doing is shifting this decimal part either bigger or, as you'll find out in a bit, smaller. And it's just by however many places is whatever number this is. That's how many places it's moved. You could think of it like this. If you either the numbers have shifted across 5 places, or if you're old-fashioned like me, my decimal point that used to be here between the 2 and the 4 has moved 1, 2, 3, 4, 5 places. So it's now off the end here. It's just when it's off the end, we don't usually write the decimal point. So my numbers have moved 5 places bigger. Right? Okay, let's write some numbers in standard form. All right, so we've got 7,200,000. I want to write that in standard form. The first thing to do is write down the decimal part, so the 7 and the 2, whatever digits you've got, with the decimal point after the first number, because that's where it needs to be for it to be standard form, because that's the rule for standard form. Then I've got to work out how many places my decimal point has moved. Well, originally, every number has a decimal point, even if it's not shown. If it's not shown, it just means it's off to the right there. So how many places has it moved to get in the right place? 1, 2, 3, 4, 5, 6. It's moved 6 places, so my number in standard form would be 7.2 times 10 to the power of 6. about this one? Okay, so first of all, write your decimal bits. So 5092. I don't need the 0 after it. I just need these bits. And there's a decimal point, which is going to be in there. I haven't really left space for it, have I? Do you know, I'm going to scrub that out. I don't like that. Let's do it again. 5.092, just to be a bit clearer. And times by 10 to a power. How far has my decimal place moved? Well, it's moved 1, 2, 3, 4 places. My number has shifted, so it's 10 to the power of 4. It's really 4 places bigger than 5.092. Next one. This one in standard form. Well, first of all, let's write the decimal with the decimal point after the first digit, so 6.609 times by 10 to the power of, well, it's moved 1, 2, 3, 4, 5, 6, 7, 8 places to be in the right place. So it's 6.609 times 10 to the power of 8. These are just ordinary numbers, just written in standard form. What about if we went back the other way, though? Let's write these as normal numbers. So they're already in standard form. They want us to write them as normal numbers. The first thing to do is probably write down the decimal bits that you've already got. So 4.62, but it's going to be 3 places bigger. So my decimal point at the moment is after the 4. So it's going to go 1, 2, 3, 4 places, and those little blank arches, we're going to put zeros in. It's just 3 places, but why did I do 4? It's supposed to be 3, isn't it? Because it says 3 there. Oh, Mr. Nice. Unfortunately, you can't go back and delete stuff on here. You just have to leave it. Or could I? We could try. No, that's not going to work. So 4,620. All right. So, you know, even math teachers make mistakes. Maybe. Right. What's the next one? 1.07 times 10 to the 5. Okay, we've got 1. And we don't want the point there. We're going to go 107. And then we're going to make it 5 places bigger from here. So it's moved over the 0, over the 7. So it's already 2 places bigger. That's 3 places, 4 places, 5 places bigger. 107,000. I'll just put a little comma in there just to make it easier to read. 107,000. Okay. Now, is there a third one? Yes, there is a third one. So 3.101. So first of all, let's just ignore that decimal point and put it 101. Now to get there, to get to 3,101, my decimal point has moved 1, 2, 3. My number is 3 places bigger already, but I need 6 places. So that's 4 places, 5 places, 6 places bigger. Let's put a little comma after those 3 digits, a little comma after those 3 digits. That's 3,101,000. That's what this number represents. 3,101,000. Right. Okay, it's your turn. I want you, in a second, I want you to click pause. I want you to write these numbers. The top numbers I want to written in standard form. The bottom numbers I want written as normal numbers. And then unpause the video and I'll show you what my answers are. Okay, so pause now. Okay, we've unpaused. In standard form then, this would be 3.5 times by 10 to the power of, well, it shifts 1, 2, 3, 4 places, so it's 10 to the power of 4. This would be 2.08 times by 10 to the power of 1, 2, 3, 4, 5, 6. And this one is 7.809 times by 10 to the power of, let's go on, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places bigger. So 7.809 times 10 to the power of 11. Right, writing these as normal numbers. Well, if we shift my number 2 places bigger, it gets to 516, but I need 4 places bigger in all, so I need another 2 places bigger. So 51,600. This one is 6 places bigger, so 701, that's 2 places bigger so far. We need another 4 places. There we go. So 7,010,000. And this one is 5 places bigger. So 5,203. That's 3 places bigger already. And I need 2 more places. So 2 more zeros there. 520,300. All right, well done if you got those right. Not well done if you didn't press pause and you just carried on straight through the video. Let's have a little look at what about if we've got these small numbers. Right, okay, well first of all, the same things we start with is 5.6. You need one digit before the decimal point, and we need to figure out our power of 10. Now my decimal place, or rather my numbers have shifted. Let's do this, 1, 2, 3, 4 places, but it's 4 places smaller. So obviously I can't just have 4 because that would make this into 4 places bigger. It would be, 56,000. So it can't be that. It's actually negative. It's minus 4. 10 to the power of negative 4. Because that makes it go 4 places smaller. So if you want it smaller, you need the negative up there. Okay, same with this one. My decimal part would be 3.07. And it's gone 1, 2, 3. Well, no, it hasn't gone 3 places, has it? It's gone 1. It's really 2 places smaller, sorry. So negative 2. 3.07 times 10 to the power of negative 2. And this one, the decimal part is 4.5. That's easy. Times by 10 to the power of, well, how many places does it need to shift to get to 4.5? That's 1, 2, 3 places it's got to shift. So it's negative 3 because my number is really 3 places smaller than 4.5. What about if we're going the other way? What if we want to write them as normal numbers then? So let's do 10 to the power of minus 3. It's got to be 3 places smaller. Right? Now this can be a little bit trickier. Let's think, if I was going 3 places smaller, it would have to jump the 4, that's 1 place, have to jump another 0, and another 0 until it's over here. Now those arches need to be filled up with zeros, so it's really going to be 0.00462. When we're going this way, it's always going to take up 1 place, jumping that single digit that should always be there for standard form, and then we've got 2 more left to do. This one we've got to go 5 places smaller. Well, it's going to take 1 jump to go over the 1. So if I had 0.107, it would have gone 1 place, but I need 4 more places. 1, 2, 3, 4 with the decimal point there. So it's gone 5 places smaller in all. Yeah. What about this one? So 6 places smaller. Well, if it was going to jump the 3, that's 1 place taken up already, so that's 1 place smaller. 2 places smaller, 3 places, 4 places, 5 places, 6 places. So 0.000003101. That's 6 places smaller. Yeah. If I show you there is another way you can do those, because some people do find those tricky. If I start with 4.62, I can actually gradually make it 3 places smaller. This does just take a bit of time though. So if I make it 1 place smaller, it would be 0.462. 2 places smaller, 0.0462. 3 places smaller would be 0.00462. So you can do that, but it takes a long time, particularly if you've got to go, say, 6 places smaller. I want you to pause the video again when I finish talking and write the top numbers in standard form and the bottom numbers as normal numbers, and then unpause it and see if it agrees with my answer. Okay, so pause now. Okay, we've unpaused. What would these numbers be in standard form? Well, that would clearly be 7.2 times by 10 to the power of, and it needs to go 1, 2, 3, 4 places. So my number is really 4 places smaller than 7.2. This one, the decimal part is 6.34 times by 10 to the power of, how many places does it need to shift? 1, 2 places it needs to shift. So my number is really 2 places smaller than 6.34. And 2.06 times by 10 to the power of, well, how many places does my number need to shift? 1, 2, 3. It really needs to be 4 places smaller. So I've got -4 on there to make my 2.06 4 places smaller. Write these as normal numbers. So my number needs to get 5 places smaller. Right. 5, 1, 1. If my decimal point jumped by 5, that's 1 place. And then we want 2 places, 3 places, 4 places, 5 places smaller by putting the decimal point there. Yep, 0.0000511. Okay, 3 places smaller than this. 309, so it's jumped by 3, so that's 1 place smaller. And then 2 places, 3 places smaller. Put a 0 at the front, 0.00309. And 7 places smaller. What was I thinking when I wrote this question? 7 places smaller. So 5204. Let's go. Right, so if it goes to make 0.5204 would be 1 place smaller, I need another 6. 1, 2, 3 places, 4 places, 5 places, 6 places smaller. So 0.00000005204. Well done if you got those right. Here is your next challenge. There are 2 worksheets to do, and it's just converting. The first one is converting standard form into normal numbers, and the other one is normal numbers into standard form. And so you need to write down whatever you think the answer is going to be. So in this case, I would put 5.93 times by 10 to the power of, well, it's really only 1 place bigger than that. So it's +1 because I really want, oh no, it's -1. Negative, of course it's -1 because I want it to be 0.593. I want my real number to be 1 place smaller. So sometimes you do need to be a bit careful about that. This one would have been 7.775 times by 10 to the power of, well, my number is really 2 places smaller than that. Or sorry, 2 places bigger than that. I'm getting confused because I'm talking quick. I really want it to be 775. So it's a +2 because it needs to be 2 places bigger to make 775. Put your answers in these boxes. It says up here how to write 10 to the power of. There's a little up arrow, so you put your number, whatever that is, times by. So I think they're using an X for that. Then 10. There's a little up arrow. If you use the up arrow, and then write whatever power you think that's going to be. So say it was 4, you'd put a 4 on the end there. All right. So that's how you're going to write in your powers there. Just it tells you. There's a little reminder on the worksheet. Once you've done them, press check answers, and it will tell you how well you've done. If you muck it up and want to try it again, you can click on new worksheet, and that'll give you new questions. The link is, or both the links are in the Show My Homework post. But in case you've lost them, they are here in tiny URL form. So just copy that. Make sure you've got your uppercase and lowercase right. Type that into the address bar, and you will get your worksheets. Okay. So good luck. Off you go.